Good morning, students. I am Ronald, Assistant Master, MDES Mysore. Now I am going to take in mathematics the second unit, triangles. In triangles, mainly we deal about similar figures and similar triangles. To know about similar triangles, before we should know congruent figures and congruent triangles. You have studied in 9th and 8th standard congruency of triangles. Congruency means the property of triangles. Congruent triangles. You see this question. What are congruent figures? Give any two examples. Two figures which have the same shape and the same size are called congruent figures. See some examples here. Squares having same shape and same size. You see, AB is equal to EF 3 centimeters. BC is equal to FG 3 centimeters. CD is equal to GH 3 centimeters. DA, HE 3 centimeters. All corresponding sides are equal. And also, if you see the inclination, what do you mean by inclination? Angles. You see angle A is 90 degree equal to angle E. Angle B is equal to angle F. Angle C is equal to angle G. Angle B equal to angle H. That means they are equally angular, you say. Then you can say these two triangles are congruent. Like that. If you see these two circles, circles having same shape and same size, how do you know that they are congruent? AM is the radius of the first circle, BN is the radius of the second circle. Two radii are equal. Here it is 4 centimeters. So I can say these two figures are congruent. You know the symbol of congruent? Congruent symbol you should write like this. Horizontal S and below that equal sign. This is about congruent figures. Like that, if you switch on to congruent triangles, say you are looking these cards. You feel it is only one card. No, there are two cards. That means triangle in shape. If you compare the corresponding sides, they coincide. So we can say these two triangles are congruent. I cannot keep like this. They are not congruent. So these two figures are congruent. If I change the order, then they will not be congruent. Therefore, it will coincide, and these two are called congruent figures. These figures are nothing but triangles, congruent triangles in which corresponding sides are equal, corresponding angles are equal. This we have learnt in 8th, 9th and all. Now we will switch on to similar figures. In this chapter, similar figures are very important. You should concentrate and learn. In this chapter mainly theorems are there. So first I am going to explain what are similar figures and similar triangles. Just now I explained about congruent figures, congruent triangles. These two are congruent triangles. Now we will see this question. What are similar figures? Give any two examples. Two figures having the same shape and not necessarily the same size. You have to see the meaning of this. Example, AB, EF, they are not equal, corresponding sides. EF is bigger than AB. BC, FG, 3 centimeters, 6 centimeters. It is increased. But the shape of the figures is the same. Size differs. This type of figures called similar figures. See, circles. Radius 4 centimeter. Radius 8 centimeter. Radii are different. Lengths they have. But the shape is the same. Two circles are similar. You see this one statement. We can say that congruent figures are similar because in congruent figures corresponding angles are equal. The ratio of the sides 1 because they are also equal. So they are also similar figures. But the similar figures need not be congruent. Similar figures cannot be congruent because the size differs. You see, now similar figures, they have some conditions. Generally they are similar. See this question. State the two conditions for the similarity of two figures or polygons. In geometry, we use polygons. We apply this on triangles, on quadrilaterals. Therefore, figures or polygons. Two polygons. What do you mean by polygon? Figures having number of sides. Two polygons of the same number of sides are similar. If these two conditions that figures must obey, their corresponding angles are equal. They should have equal inclinations. And their corresponding sides are in the same ratio. Corresponding sides ratio. Equality of ratios, proportional or proportional. Therefore, if the figures obey these two conditions, then you can say easily that two figures are similar figures. Students, you see the conditions for similar triangles. I can ask the question, fourth one, like this. State the two conditions for the similarity of two triangles. Give one example. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Ratio means the comparison between two quantities. Proportion means the equality of two ratios. See this example. In triangle ABC, AB is 4 centimeters, AC is 4 centimeters, BC is 3 centimeters. Correspondingly, D is 8 centimeters, DF is 8 centimeters, EF is 6 centimeters, respectively. See the angles. Angle A 50 degree, angle D 50 degree, angle B 60 degree, angle E 60 degree, angle C 70, angle F 70. They are equiangular. Like this, if in any two triangles, if the angles are, corresponding angles are equal and the sides are proportional, then you can say that two triangles are similar. The symbol is triangle ABC. This is the symbol for similar triangles. Similarity between two figures, triangle DEF. Because you see the ratios I have taken, corresponding sides AB by DE is equal to 4 by 8. If you simplify, 4 ones are 4 twos are half centimeter you get. Take another corresponding sides ratio BC by EF 3 by 6. You divide it, you will get half centimeter. And the third sides ratio AC by DF 4 by 8 is half. When the ratios of two triangle sides are equal, then you can say that two triangles are similar. Students, you see this one activity. Here, one triangle is smaller. Behind one triangle is bigger one. I can separate this, but angles are the same, equiangular. See, angles, that inclination are the same. 60 degree, 70 degree, 50 degree. Same vertex angle 50 degree, base angles left is 70 degree and right is 60 degree. So these two triangles I can give for similar triangles. Non-similar figures means different properties. You see this question. Give two different examples of pair of non-similar figures. A square and a rectangle. You know that a square is a quadrilateral and all the sides are equal. If you compare that with a rectangle, it has different sides. Opposite sides are equal, but different. If you compare the corresponding sides, or not equal, may not be equal. Such type of figures are called non-similar figures. Square the rhombus with a square in which all the sides are equal. In a rhombus also, in a rhombus, all the sides are equal. But having different angles. Angles are not equal. Corresponding angles are not equal. So they are non-similar figures. Students, now I will read one question here again. State Thales theorem. Mathematician Thales explained and gave this concept. It is called basic proportionality theorem. What is a theorem first? Theorem is nothing but true statements that can be proved by logical steps in precise. So, he gave one statement about proportionality of triangles. His statements tells like this. If a line is drawn parallel to one side, in a triangle there are three sides, you can draw parallel to any one side of a triangle to intersect the other two sides. In distinct points, separate points, the other two sides are divided into in the same ratio. See, you compare that with this triangle. If a line is drawn parallel, you take DE is drawn parallel to BC. You can draw the line DE parallel to AC, or you can draw the line DE parallel to AB. But here, I have taken one parallel lines, DE parallel to BC. So, the line drawn parallel to one side of a triangle, it intersects, means to intersect the other two sides. It intersects other two sides, AC and AB, AB at D, AC at E, separately, that is distinct distance. The other two sides, so when it joins or intersects the other two sides, it will divide the line AC and AB in the ratio. That ratios are equal. So he says, when you draw DE parallel to BC, then AD by BD, the divided portion, is equal to AE by CE. That ratios are equal. I can call it as a proportion, comparison of ratios. Students, now is very important to prove Thales theorem. In this chapter, this theorem is numbered as theorem 2.1 called Thales theorem. So the question in your exam they may ask like this. Prove that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. When you get a triangle, you should know the prerequisites about that, means basic knowledge To prove this, we need some basic formula. I will write right hand side of the board. Area of a triangle. I use this to prove that is half base into height, half base into height, square units, square units. And then we need the altitude, the height. If you take a triangle, if you take a triangle, the vertex point joined to its opposite base is the altitude, height of the triangle. So height of the triangle is nothing but, in this figure, AB. So you need the formula and this height. And in 9th standard you have studied about the triangles between same parallels having same base or equal. You can remember that. I will apply that on this theorem. And when you take a theorem, first you have to draw the figure, and observing the figure, you write the data. So now you have to write the data that is given like this. In a triangle ABC, DE parallel to BC, DE intersects AB at D and AC at E. This is given hypothesis. And what you should prove, conclusion to prove is, when the line drawn parallel to one side of the triangle, it divides the other two sides in the same ratio. That means this D divides AB and D. Therefore, AD by BD, the ratio AD by BD is equal to AE by CE. And to prove now these ratios are equal, for that I have to construct draw perpendiculars from B from E. These are the perpendiculars marked as M. DM is the perpendicular line, EN is the perpendicular to this side AD, and join BE. This is the construction. So, students, I can write that in this step construction, join BE and CD, join BE and CD, and then draw DM perpendicular to AC, perpendicular altitude, EN perpendicular to AB. So the steps you see given, that's the data. to prove construction, then we can prove. You take first area of triangle ADE. I can take this triangle ADE, you see. You know that in triangle ADE, half into base is the base into height is the area of the triangle. They are half base. If you take AC is the, I will take here AE as the base in ADE. So I can write the area of ADE. If I take AE is the base, half into AE into the altitude on the same base, that is DM. So I can write the same here. If you take, this is the BDE triangle, and take the area of BDE. It is the same triangle, you see. It is an obtuse angle triangle. The height is outside the triangle. So I can take the area of BD is nothing but BD is the base, half into BD into the height. The height is EN. See students, like this you have to collect the areas of triangles. The same triangle ADE also can I write the base into height, you see. If you take AD is the base, then you can write EN is the altitude, height on the same base. If you take AE is the base, on the base DM is the height. So if you take ADE, if you take AD is the same one, AD is the base, EN is the height. If you take your triangle CDE, I can write here CDE mark like this. So CDE, what is the area? Half into base into height, that is DM. Now you divide, and the common one DM take the ratio, and EN take the ratio. I can write like this. Area of ADE divided by area of BDE is equal to half into ADE. You take EN one, common one, BD into EN, half here AD into EN, and here BD into EN. So I cancel this, then you will get AD by BD, the first ratio, that is area ADE divided by area BDE. You take this as 1. See students, again you take the heights DM, you divide these two, that is nothing but half into AE into DM of area of CDE So half dm they got cancelled. Therefore I can write area of ADE by area of CDE is nothing but AE by CE. Take it as the second one equation. And you see one thing here, and I told in 9th standard you studied the areas of triangles on the same base between the parallels are equal. Here if you take B as the base, if you take this is the base, then on the same base, two triangles CDE and BDE, and between the same parallels, if you see, same parallels, so that areas are equal. Therefore, I can write area of BDE is equal to area of CDE. Therefore, from 1 and 2, we can conclude that area of ADE by area of BDE. Area of ADE, numerators are equal. CDE equal to BDE. I can write because triangles on the same base and between the same parallels are equal. Therefore, if you observe BDE equal to CDE, left hand sides are equal. Therefore, area of ADE by area of BDE is equal to area of ADE divided by area of CDE. When left hand sides are equal, therefore I can write AD by BD is equal to AE by CE. You can write CE as EC. You can write like that. So the theorem is proved. What it says? When a line drawn parallel to a side divides the other two sides proportionally, the ratios are equal.
Same.
Students, here triangles on the same base and between the same parallels are equal. So the triangles are equal in area. Then I substituted that. So you got that. In the theorem, students, first you collect the area of triangle ADE, both the sides from right and left, ADE, and area of BDE and area of CDE, and for the area of triangle BDE, the height the same which is on ADE, and the area of triangle CDE, the height on AE. Because BDE and CDE are obtuse angle triangles, the heights, altitudes lies outside the triangle. So you see that, and then you see your assignment given. Fill in the blanks. All circles are dash, congruent or similar. All dash triangles are similar. Isosceles or equilateral. State Thayer's theorem. You write the statement 2.1 and prove that theorem. You write this theorem on 3-4 times in your notes and also in your homework on 2 times, then you will understand this theorem. Students, I hope you have understood this theorem. Thank you very much. Have a nice day.